Okay, listen. Today we are going to uncover a massive secret. It's a secret that literally governs almost everything around you, yet it's entirely invisible to the naked eye. This explainer is proudly produced by Dr. Nima Mahadian, and we are diving deep into control engineering. Now wait, don't let the word engineering scare you off. Seriously, by the end of this breakdown, you're going to see how this hidden intelligence applies to everything. And I mean everything, from advanced robotics all the way to human psychology and biology. So no matter what your background is, you use this every day. It is the hidden brain behind modern civilization.
To really wrap our heads around this, we need to start by looking up. Picture a drone hovering right there in the middle of a park. The wind is whipping around, the air pressure is fluctuating, gravity is constantly trying to pull the thing down to the dirt, but it just stays perfectly suspended in midair. It's like it's nailed to the sky. Why doesn't it just flip over and crash into the grass?
Or hey, think about this one. You're cruising down the highway going, say, 70 miles per hour, and there's a Tesla right next to you navigating a gentle curve in the road. The driver doesn't even have their hands on the wheel. There are bumps, the wind is slamming against the chassis, tire friction is changing by the millisecond, yet that car stays flawlessly centered in its lane. Seriously, how is that even possible?
Let's bring this mystery right into your own home. You walk into your living room, you punch 72 degrees into your thermostat, and you completely forget about it. Outside, the sun goes down, the temperature plummets by 20 degrees, the wind is literally howling against your windows. But inside, it stays at exactly 72 degrees. It never freezes, it doesn't turn into a sauna, it just effortlessly locks onto that target.
All right, let's raise the stakes here. Think about the entire power grid of your country. Millions of people are turning on their microwaves at random times. Giant factories are firing up massive machines. Whole cities are switching off their lights. The demand for electricity is wildly fluctuating every fraction of a second. If the supply of power doesn't perfectly match that chaotic demand, the entire grid collapses into a total blackout. So, why doesn't modern civilization just go dark every single minute?
Well, the invisible force answering all of these mysteries comes down to just 3 words: controlled by feedback. That's it. Every single one of those examples, the drone in the park, the car on the highway, your living room, the massive power grid, they all rely on a mechanism called a closed-loop feedback control system. It is literally the invisible nervous system of our modern world. And it's amazing how this one single concept connects completely unrelated worlds. Branching out from a central controller, you've got aerospace and aviation, the automotive industry, robotics, massive HVAC systems controlling our indoor climates, life-saving biomedical systems, and those gigantic power networks we just talked about. All of these incredibly different industries are united by feedback control. Think about it. The exact same logical framework that keeps a multi-million-dollar rocket upright is the same thing keeping your leftover pizza cold in the fridge. So, how does it actually do this? Well, it all boils down to a brilliantly simple 4-step logic. Step 1, the system measures its current state using a sensor. Step 2, it compares that measurement with your desired value, the target you set. Step 3, it calculates the error, meaning the exact difference between where it is right now and where it actually wants to be. And finally, Step 4, it corrects the system by taking action to close that gap. Measure, compare, calculate, correct. Over and over, thousands of times a second.
And that brings us to what is honestly one of the most powerful, tiny equations in the world. E of t equals r of t minus y of t. Now don't let the math letters intimidate you. It's beautifully simple. The error at any given moment is just the reference, which is your target, minus your actual current output. Calculating this tiny error is what keeps modern society running. Because think about it, without figuring out exactly how wrong a system currently is, it has absolutely no idea how to make itself right.
Of course, taking that math and putting it into the real world takes incredible human ingenuity. Control engineers are the ones who take that exact mathematical logic and bake it into physical reality. They design systems that link computer controllers to physical flow meters, industrial tanks, and giant valves. They are basically building a mechanical nervous system, making sure the sensors perfectly talk to the computer and the computer can physically turn the valves to fix the flow.
Let's dive a little deeper into how that electronic brain actually thinks, using something called PID control. Think of an analogy we all know, a car's cruise control. The P stands for proportion. If the car slows down slightly on a hill, it taps the gas. The I is integral. If that hill is super long and you're stuck going too slow for a while, it adds up all that past error and says, hey, push the pedal even harder. And the D is derivative. It basically predicts the future. As you finally get up to your target speed, it tells the car to ease off the gas so you don't overshoot. So it reacts to the present, remembers the past, and predicts the future.
And that specific PID logic isn't just for cars. It's running quietly in the background everywhere.
When a sudden gust of wind hits that hovering drone, the controller instantly calculates the PID error and tweaks the propeller speeds to stabilize it. On the power grid, when electricity demand suddenly shifts, a controller detects the error from the target 50 Hz frequency and instantly commands massive generators to spin just a tiny bit faster or slower. When your room sensor reads 22 degrees instead of 24, that exact same logic tells your heater to kick on.
But okay, let's play a little game. I want you to imagine something genuinely terrifying. What happens if we just flip the switch? What if we completely sever that loop and turn the feedback off entirely? Imagine a world that suddenly loses this hidden brain.
Absolute, unmitigated chaos. Without feedback, modern life would become unstable in a matter of seconds. Systems would immediately drift off target. Your car on autopilot, right into a ditch. Your heater, it would run forever until your house literally caught on fire. You'd see these incredibly dangerous oscillations as machines wildly overcorrected themselves blindly. Ultimately, it leads to complete system failure. Without feedback, we really don't have technology. We just have runaway machines.
If you chart it out, an unstable response looks like a jagged line shooting violently up and plunging right back down in these wild, terrifying swings. A tiny disturbance hits the system, and instead of fixing it, the system just loses its mind and swings out of control. Now contrast that with a beautifully tuned, stable response. A disturbance happens, the system might dip momentarily, but then it gently and smoothly settles right back onto its target line. That solid, smooth line, that's the holy grail for every control engineer.
But here's the catch. Achieving that smooth line isn't automatic. Engineers have to perfectly tune these mathematical formulas to keep things stable. Why? Because a feedback loop can actually trigger its own instability if you push the variables too far. Engineers have to carefully calculate the roots of these equations. If a variable gets too large, the system overreacts to its own corrections, and the feedback loop itself causes the disaster. So balance is literally everything.
Okay, now I want to completely shift how you think about all of this, because this is where it gets really mind-blowing. The most fascinating thing here, and Dr. Madian emphasizes this constantly, is that control engineering isn't just for robots or factories. Feedback control is the universal language of behavior. Whether you're an expert in robotics or someone studying human psychology, the principles are identical. Think about it. When a therapist helps a patient recognize an anxiety trigger and they work to adjust their behavioral response to get back to a baseline calm, that is a closed-loop feedback system. You are measuring the error and correcting the system.
We can literally map this stability across both engineering and nature. Yes, we have aircraft autopilots, sure, but look at climate systems using vast feedback loops to regulate the Earth's temperature. Ecosystem dynamics rely on predator-prey feedback to keep animal populations from exploding. And biological homeostasis, the way your human body sweats to cool down or shivers to warm up. You are literally a living, breathing PID controller. Control engineering is the fundamental framework for understanding all complex behaviors in the universe.
So if you take away just one thing from our explainer today, let it be this powerful summary from our source material. Control engineering is the hidden intelligence behind modern technology. It is the invisible mathematics of balance, working endlessly, quietly in the background to ensure that our world, our machines, and even our own biological bodies don't collapse into chaos.
So, the next time you set your cruise control or see a drone hovering in the sky, or honestly just take a deep breath to calm your own nerves, ask yourself, how is feedback secretly running my life right now? The world is full of these incredible mysteries hiding right in plain sight. If you want to keep unraveling them with us, be sure to subscribe to Dr. Nima Madian's channel, where we're going to keep uncovering the hidden rules that shape the world around us. Keep questioning, keep learning, and we'll see you next time.